So you may face this question in your next interview. So what is a happy number and how you can identify it? So we have 19 and 19 is having digit 1 and 9, right? Now you need to square these two. So if you'll square 1, it would become 1, and if you'll square 9, it will become 81. Now if you'll do the summation of these two, it would become 82. You will repeat the same step. Now 8 square 64, 2 square 4. Now you will do the summation, it becomes 68. Then you again repeat it. It becomes 36 and 64, which is 100. Now you repeat the same step, it would become 1 square and you have 0, 0, so that becomes 1. So if you will continue doing these steps and at the end you find 1, that is a happy number. 19 is a happy number. Let's do the same thing with 4. So 4, if you'll do the square, it becomes 16. Now if you'll do the square of 16 individual digits, it becomes 1, and this is 30, which will be 37, right? Now with 37, if we'll do the square, it becomes 9 and 49, that is equals to 58, right? Similarly, if I'll continue, it becomes 89, then it will become 145, then it will become 42, and then it will become 20. Eventually it becomes 4, which is a repeating, right? So you are not going to get 1, so there would be a loop detected, right? So this is where it is not a happy number. Okay, now let's check the output. If you'll see, I have taken 19 and I'm calling this find if function. I got true. Now if I change it to 4 and I'll rerun, you see it is false. Okay, this is working fine. Now let's understand the code. Now let's see this function. Here if you'll see, we are taking two magic numbers. When your number is less than 10, that means single digit, we know there are two possibilities of happy number, that is 1 and 7. So in these two cases, we are directly taking these two values and returning true. Otherwise, we are extracting this individual digits or single digits out of it and then doing the square using the remainder method, right? We are doing the remainder and then getting the value using the method floor and again running the loop till it is 0 and getting the sum of it. Once we got the sum of it, what we are doing, we are recursively calling the same function. So if you see this function, right, you will know that if for any digit you are calling this happy function, you are basically doing a log n, right? The log n is for this certain logic, and we are doing this log n, let's say for k times. So k times log n is getting executed, right? K times log n is getting executed. So your time complexity to this should be k into log n, which is eventually your log n. Okay, so your time complexity is log n, and as we know, this is a recursive function, so your call stack will decide your space complexity, as this is going to be occupying some space while getting executed, so it will eventually have a log n space complexity as well.